September 2017. A Danish Royal Air Force C-130, carrying an international team including APL-UW climate scientist Ignatius Rigor,
Drop.
embarks on a mission to deploy buoys in the central Arctic Ocean.
These buoys that we're deploying are airborne seasonal ice beacons. It's basically designed to be able to throw it out on the Arctic Ocean. It's pretty tough. It's able to survive freeze-thaw cycles. It's able to survive storms and ice crashing into it. The buoys measure basic meteorology. And they have GPSs, so we know where they are. The data is transmitted up through various satellites into the National Weather Service, so it's used for weather forecasts. It's also transmitted to the National Ice Center, and they use it for ice tracking and making their ice charts. Every weather forecaster or ice analyst can get the data in real time.
In the spring of 2017, APL-UW's Polar Science Center's International Arctic Buoy Program, a global collaboration of more than 30 research and operational institutions, carried out a buoy deployment mission aboard a Danish C-130.
For this one flight, we had buoys from Canada, buoys from the U.S., a Royal Danish Air Force plane, and personnel from O&R, a couple civilians to help piece the buoys together and make sure they're ready to go.
The buoys are designed to be dropped into open water, gaps in the ice cover known as leads.
Once we see a lead picked out, the pilots will mark it on their navigation systems, and they'll swing back around. We'll drop down about 300 feet. We'll push them out of the airplane. The first time I did it was pretty nerve-wracking. The back door opens and you see the ice out there. As the buoy hits the water, all the MET sensors pop up so that we measure air pressure, temperature, and surface temperature.
Ignatius Rigor coordinates the International Arctic Buoy Program, the IABP. A major challenge is getting buoys deployed in the high Arctic, especially on the Eurasian side of the ocean.
We've had a lot of trouble getting buoys on the Russian side. The winds just blow the ice and the buoys pretty quickly away from the Russian coast. Access is a lot harder. We need to get permits from the Russian government. These buoys are, measure fundamental meteorology. And it's, things like air pressure are just required by all the models to make an accurate weather forecast. The Arctic Ocean is an area the size of the United States, and we only, you look at the United States, we have thousands of weather stations spread all across the country and into the Pacific to help with our weather forecasts. In the Arctic, we have 100.
Now including the half-dozen airborne seasonal ice beacons successfully deployed in the fall of 2017.
We see this as basically a proof of concept. We showed that we could rally, many different agencies and groups to deploy, some weather stations that we all need. The hope is that next year we may, stage in Thule as well as alert in Canada, and that'll allow us to reach farther into the Arctic and hopefully get to the Russian side. This is basically the first step in hopefully a recurring collaboration.
Science at work for you. This is APL, the Applied Physics Laboratory at the University of Washington in Seattle.